Okay, so let us now consider this solid cylindrical conductor, okay, with of course a radius r, okay, and then meron siyang mga charges, okay, denoted by plus here or positive here, yun yung mga plus na yun. So those are the charges, okay, and they are assumed to be uniformly distributed, no, on the conductor surface, okay. Now, di ba we mentioned that the internal electric field, okay, of this conductor is 0. So, ang point of consideration natin ngayon will be the electric field that is outside the conductor. Okay? So, yung surface na yon will be chosen here. So, or represented here yung sa dashed cylinder. Okay? Yung dash na yon, no? Okay, so yung radius will be like x that is greater than the radius of the conductor. Kasi nga outside eh. Okay, and then our assumption is for our differential element or surface area, yung 1 meter na conductor. Okay, so by the way, yung charges natin here, ang assumption is from positive to negative, no? So, the arrows here represent the direction of the electric field lines, no? Yung from the charge, okay? Kasi nga may charge siya, so definitely there is an electric field, okay? So, making use of Gauss law, okay? We'll have to now integrate this. So, it will be simply, of course, yung E natin is permittivity. Okay, in this case, it will be equal to permittivity of free space. No, so that is 8.854 to the negative 12 farad per meter. Okay, so since that is constant, lalabas lang siya. And then the E normal here, or the electric field strength, that is the normal component, no, will be EX. E of X. Sorry, no? E of X. Kasi yung X yung ating parameter here. And then the differential surface area will be 2 pi x1. Okay? And then the enclosed here is Q1. Okay? So, since we are after the electric field, so simply rearranging electric field is Q over 2 pi x E of X. EX. Okay? Hindi E of X, so hindi sub. So, E times X. Okay? Yan. Now, since we're done with the electric field, so sabi natin kanina, another parameter to obtain is the voltage. So, the voltage between points 1 and 2. Okay? So, points 1 and 2 are shown here. So, yung point 1 has a distance from the radius to be D1, and D2 will be the distance from the radius of P2. Okay? So, V12 will be obtained by integrating from D1 to D2 the EX dx. Okay? So, since we had already our EX, so lagay lang natin siya, V12, D1, D2 integral, EX will be Q over 2 pi EX dx. Right? And then, lalabas lang natin yung 2 pi E. Then, we'll have dx over x. Okay? So, a simple integral here. Integrate natin yung 1 over x dx. That will simply be ln of x evaluated from d1, d2. So, that will be ln of d2 minus ln of d1. Alright? So, properties of natural logarithms will give us ln d2 over d1. So, that's why yung V12 natin, so after integrating, will give us Q over 2 pi E ln of d2 over d1. Okay? So, that's electric field, and then the voltage or potential between P1 and P2. Okay. Next is getting the potential difference between K and I, alright, K and I conductors. Okay, that is due to all the charges na. So, kung consider na natin yun, no? So, from the previous derivation, we have V12, okay, between points 1 and 2 only, no? 1 and 2. And parang particular lang siya dun sa effect of a charge. Now, we'll consider all the charges. So, in this case, pattern lang natin siya here, no? So, yung V1 and 2 is yung KI. Okay? So, conductor K, conductor I. Okay? So, 1 over 2 pi E. So, yung Q natin, since we have several charges, magiging QM na siya. Okay? Summation of na siya, no? Kasi ano na siya several charges, hindi lang one charge. Okay? So, it will be summation of QM, alright? Ln of yung D2 now here becomes DIM. Okay? And your D1 is DKM. Okay? So, magbabago yung IM, KM, depending on what charge is being considered. No? So, magbabago yun. We'll make use of this equation, the general equation, no, potential difference or voltage between between two conductors with actually parang two conductors, pero because of or we are taking into account the effect of all the charges. Okay? So again, kasi nga the charges, kumbaga, because there is a charge, there's electric field. No? So, may electric field ka, meron kang voltage. So, that's why magte-take effect ngayon itong mga charges mo. Okay? Okay. So, this VKI formula or equation will be used, okay, in developing the capacitance equations for all the remaining configurations na we mentioned in our introduction. So, from single phase and then three phase, etc.